Okay, you've had a few minutes to work on these. Let's take a look at them. The first one here, so it's supposed to be subtraction, but it looks like I got addition, so we'll add it. What do we need to do? Common denominator, which will be 24. What's this one come out to be? And 20 times 4. So we add those together, we're going to get 29 24s, which of course is 1 and 5 24s. Perfect. So 5 24s carry the 1, that's 12. 12 and 5 24s. How many you got that? Cool. Next one. Do you know what you did wrong? Okay. How about over here? Okay, so this will be 33 fourths, right? 21 fifths. And then? So this will be 5 21st. We flip the second one, the one we're dividing by. Perfect. We divide out the 3. 55 over 28, which is 1 and 27 28. How many of you had that? What's that? You got her now? Good.
Yeah, yeah. Long weekend.
Sure. Did I show you guys how to use the fraction button on your calculators?
What?
The fraction button on your calculators?
Yeah.
All of your calculators, depending on what you have,
You guys said to get.
Yep, you guys have a key that looks like this, ND, or it might just be a box over a box. And above it, it'll say UND like this.
Gotcha. Yep.
The rest of you have an ABC key. For those of you that have this key to enter a fraction, you just press the key. And then use the arrows to enter the numbers in it. Then you got to use the right arrow to get out of it to put the next thing in. If it's a mixed number like this last one here, the 8 1/4, you have to use the shift or the second key and then press that key. Generally what you do is you press the whole number, the 8, then you shift and then that key. That'll give you the fraction part. For those of you that have the ABC key, to enter 8 1/4, just use 8, ABC 1, ABC 4. Then divided by, and enter in the, was it 4, ABC 1, ABC 5. Did you get to work?
Yeah, I'll do that. I'll do the old-fashioned way.
Well, if you can get that button to work, it is a tremendous speed boost.
I'll have to do it when I wear my glasses.
Oh, gotcha. When you can actually see what the buttons say?
Yeah.
I hear you. Did you guys all get it to work? The 8 1. If you can do it, try 8 1/4 divided by 4 1/5. See what you come up with. Okay, yep. And then do you know how to reduce it on there? Okay, so on that calculator, there is a...
Is it ND to UND?
Yep. So you might have to hit shift and then the ND to UND key. Then hit equals.
127.
Perfect.
No harm in fractions.
Yep. You guys, anybody over there not get it to work? Anybody need help? Got it to work?
I've known how to do that since 7th grade.
Okay, perfect. Okay, so one thing I want to go over with you guys: threading. 1 and should be 1 and 27 28. So you have 1 with a little on your display. It'll be like this: 1, 27, 28, something like that, or like this.
Yeah, I thought maybe my calculator was bad because it looked like it was starting at 0.
Yeah, it's just a weird little thing. If we're talking about bolts and threads, you might have like a 3/8 inch 20 NF. What the 3/8 inch is referring to, the diameter of the shaft of the bolt itself. This right here. That's 3/8 of an inch. The 20 NF stands for 20 National Fine, and what that is threads per inch. So this saying is on 1 inch of bolt, there will be 20 threads. So if I take a nut and I turn it onto this bolt, if I turn it 20 times, how far is it going to go? An inch. If I turn it 10 times, 10 rotations or revolutions, how far is it going to go? 10/20ths or 1/2 inch. If I turn it 5 revolutions, 5 out of 20 or 1/4. Does everybody see where the 20 is coming from in this fraction? It's 20 threads per inch, so 20 revolutions would be a full inch. So 10 revolutions would be 10/20ths. 8 revolutions would be 8/20ths or 4/10ths or 2/5 of an inch. Okay, I just wanted to point that out before we started our quiz. I realize there's some of you still working on the quiz, and again, as always, please feel free to take as much time as you need to finish it up. But we're going to go ahead and take a look at our new material for today. So if you'd set it aside for just a minute and stick with us here. So what we're going to look at today, we're going to move on to the next topic, which is decimals. And to understand decimals, the key to it is to go back to one of the topics we discussed in our first couple of days, and that is place values. You have the ones, tens, hundreds, 1,000s, 10,000s, and so on. And as we look at those place values, what we'll notice is if we move one place to the right, one spot to the right, the place value is divided by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 10 divided by 10 is 1. So if we were to keep going on the other side of the decimal point, 1 divided by 10 would be 1/10. Divided by 10 again would be 1/100th. 1/100th divided by 10 is 1/1000th, and 1/10,000th, and so on. You'll look at these place values and you realize they look a lot like fractions, because that's all a decimal really is. It's just a short way of writing a fraction that has that denominator that's a power of 10. Also, you'll notice, because I get this question a lot, over here it's ones, tens, hundreds. Over here there is no ones or once place. It's tenths, hundredths. And it's because of this dividing by 10 as you move every position. So if I have 0.34, that is pronounced 34 hundredths. The place value that the last digit is in is the name of that decimal. And you'd write it as 34 over 100. It is really that simple to convert a decimal to a fraction. What's that? 34% if you're looking at percents, yes. A decimal really is a fraction. It's just that. Now, as a fraction, of course, we would reduce this because both of those numbers could be divided by 2, which would give us 17/50ths. So what if I have 0.0375 as a decimal? How do I turn that into a fraction? 375 of 10 thousandths. Perfect. Because tenths, hundredths, thousandths, 10 thousandths. Okay. Well, one little trick I want to show you, by the way, just to double check if you're doing 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in your denominator. To reduce it, we can divide by 5. Very good. Which is going to give us 2,000 on bottom and 75 on top. Now what? Divide by 5 again. She'll have 15 and 400. And of course, dividing by 5 one more time gives us 3 over 80. So 0.0375 is 3/80ths. What if I have 9.685?
9,685,000.
Perfect. The 9 is a whole number. So this is actually just like a mixed number, a mixed fraction. I have the whole number, the 9. Doesn't get affected at all. Then it is 685 tenths, hundredths, thousandths, so over 1,000. What can I do with that? I can reduce by 5, which is going to give us 200 there, 137 on top. Is that it? I need the 9. Very good. Yeah, the 137 and the 200 cannot be reduced anymore together. But I do have to remember the 9 up there. Well, let's take a look at some of our operations with our decimals now. If I have 17.34 plus 9.682. What do I have to make sure I do when I go to add these? Line up the decimals. That's been pounded into you since about 3rd or 4th grade. Why do we line up the decimal?
So the values are equal.
Exactly. Remember, when we talked about addition, we can only add or subtract things that have the same name. That goes right down to the individual digits. Lining up those decimal points, make sure I have the ones with the ones, the tenths with the tenths, and hundredths with the hundredths. Now, once it's lined up, I probably should put a 0 in here to fill that out. And now I'm just going to add my column. 0 and 2, 4 and 8, 12, 2 carry the 1 just like before. So that's going to be 10, so 0 carry the 1. Now, before I add that next column, what should I do? Bring my decimal point straight down. The reason we bring it straight down is when we add or subtract, we keep the same name. Bringing that decimal point straight down makes sure the tenths stay tenths and the ones stay ones. So here I have 8, 17, so 7 carry the 1, and 2. 27 and 22 thousandths, or 27.022. That is an acceptable way of saying it. It's kind of the cheap. Some older math teachers would swat your hand with a ruler for saying 0.022, but it is acceptable. We're not going to spend a lot of time with addition. Subtraction is slightly more interesting. So something like this. Again, we have to make sure we line up the decimal points. We go to subtract. Here it's actually vital that we put that 0 in to fill that place. So now, yeah, we can't subtract 0 minus 2, so we're going to borrow from the 3. This is a 2, and this is a 10. 10 minus 2? 8. I have to borrow from the 6. This will be a 5 and a 12. 12 minus 7? 5. 5 minus 4? 1. Now we bring the decimal point straight down again. Borrow from the 8. That's a 7. This is a 17. 17 minus 9? 8. And 7 minus 3 is 4. So 48.158. Something I'd like to point out is this one. When I go to do this one, first of all, where's the decimal point in the 8? At the end. Any number that doesn't have a decimal point expressed in it, the decimal point is at the end of it. So we put that there, so we're going to have to make sure we line up with that. And of course, we should fill in our missing zeros. Now, when we go to subtract here, 0 minus 4, of course, can't be done, so we need to borrow. But there's nothing here to borrow from. So what do we have to do? We go all the way to the 8. We're going to borrow, that's a 7. This becomes a 10. Well, we need it all the way down here, so we have to keep borrowing. That's a 9 and a 10. Borrow again, 9 and 10. Borrow again, 9 and 10. Of course, a lot of you probably were taught the shortcut, just go 9, 9, 9, 9, 9, 10 at the end. So go ahead and subtract here. 10 minus 4, 6. 9 minus 9, 9 minus 3, 6. And 9 minus 7, 2. Before we can do the 7 minus 2, bring down the decimal point. Now 7 minus 2 is 5. Okay, easy enough. When we multiply, do I have to line up the decimal point when I set this up? No, I do not. When we multiply or divide, we do not need the same name. I'm going to put the decimal points in there, but when I do my calculations, I am going to completely ignore them for now. And then we're going to multiply just like we would whole numbers. 8 times 5, 40, so 0, carry the 4. 8 times 3 is 24, plus 4 is 28, so 8, carry the 2. 8 times 7, 56, plus 2 is, so 8, carry the 5. Now before we go to the 4, we've got to do a couple things. What's one of them? Put a 0 in there. Then I usually put a line up here just so we keep track. 8 times 5, or 4 times 5. 20, so 0, carry the 2. 4 times 3, 12, plus 2, 14, carry the 1. 4 times 7, 28 plus 1 is 29, so 9, carry the 2. And we just add our columns now. I got to keep the 0 here for now. 8, 12, so 2 carry the 1, 15, so 5 carry the 1, and 3. Where's my decimal point going to go?
3, 5, 2.
Between the 5 and 2. And somebody said 3 from the left. 1, 2, 3. Why? Exactly. And then we've been taught to count in the problem. 1, 2, 3 decimal places in the problem. 1, 2, 3 decimal places in our answer. Another way you could look at that, if we're estimating, this is about 7, this is about 5. 7 times 5 is 35. It wouldn't make sense to have 3.528, and 352.8 wouldn't make sense either. That is the only spot it makes sense to have our decimal point in that answer. However, try that one in your seat. See what you come up with. And we'll go over it in just a second. Oh, let's run through it. See what you came up with. Now, first of all, I'm looking at this. I got about 60 times 3. I'm expecting something close to 180. I'm going to keep that in mind. 6 times 9. So 4 carry the 5. 6 times 3. 18 plus 5 is 23. So 3 carry the 2. 6 times 6. 36 plus 2 is 38. So carry the 3. Bring down a 0. 5 times 9. So 5 carry the 4. 5 times 3. 15 plus 4 is 19. Carry the 1. 5 times 6. 31. Now before we go to the 2, we have to do 2 zeros because it's 2 spots over. 2 times 9. 18. Carry the 1. 2 times 3. 6 plus 1 is 7, and 2 times 6 is 12, carry the 1. So 4, 8, 25, carry the 2, 13, carry the 1, 6, and 1. Decimal point goes right there. 1, 2, 3 in the problem, 1, 2, 3 in the answer. Again, we're expecting something around 180, so 163 is the only thing that makes sense there. How many of you got 163.584? Cool. How many of you are on your way there just ran out of time? Okay. Division. As we've discussed before, division is the one operation that has just been totally twisted and made totally unfamiliar. So this first example I'm going to show you is going to be the old way, the real way of doing division. Let's say I have something like 48.689 divided by 3.7. The way this used to be done is you'd pick a place value. I'm going to pick the first digit of the number I'm dividing. That's the tens place. So 10 times 3.7 is 37. Can I subtract that? Yes, in fact, I can subtract it exactly once. So that's 10 times 1. I just subtracted it 10 times. 1 and 1, bring down my 6. Next place is the ones place. Times 3.7 is 3.7. Can I subtract that from 11.689? Yeah, probably can't quite do it 3 times, can I? No. Actually, no, I can do it 3 times. 3.7 times 3 is 11.1, isn't it? Let me double check me. 11.1, right? 11.1, so it does work. So times 3 is 11.1. That's 3 times 1, or 3 more times. I'm going to get 0.589. So I do the 0.1, or the tens place, times 3.7 is 0.37. Can I subtract that? Yeah, in fact, exactly once. So I just did it 0.1 times, giving me 0.219. Next place value is, of course, the hundreds place. So that's 0.037, which I can subtract, what, 6 times maybe? Times 6 would be, that's not going to go, is it? Yeah, so I did times 5. 5 times is going to give me 0.185, which is 0.034. So that's 5 times 0.01, so that's 0.05. Get the picture?
Yeah,
It's really long and tedious, yes, but very straightforward. Just exactly like what I showed you with the whole numbers way back when. Of course, you bring that all together, that's 13.15, and you're going to keep going. So let's look at how we were taught to do this. How are we taught to divide by decimal? Well, technically, we were taught not to divide by decimal. What we were taught to do is move the decimal point over one spot to get rid of the decimal and what we're dividing by. So we have to move the decimal point over one spot there. Question is, why are we allowed to do that? Because division and fractions go together. Any division problem can be turned into a fraction. Any fraction can be turned into a division problem. So if I'm looking at that fraction, if I want to get rid of the decimal point down here, I just multiply by 10, moves it over a spot. But if I multiply the bottom, I got to multiply the top. So there's 2 decimal places, I'd multiply by 100, top and bottom. So this now becomes 37 into 486.89. And let's say I want that to the nearest thousand. So 37, does it go into 4? No. 48? Once. Bring down the 6. Goes in 116. 3 times. It's 111. There's 5. Before I can bring down the 8, I have to move up my decimal point. 37 into 58 is once. Bring down the 9. That would be 5 times, right? 185. Now what? We can add zeros, bring it down. 37 into 340. 9 times is what, 333?
But now you can stop it. Only after 1,000.
Well, I said to go to the thousandth, so I'm at the thousandth digit. Can I stop?
Yep.
Technically, I got to add one more zero and bring it down. 37 goes into 71s. Why did I have to add that one more zero? Because if this would have been a 5 or bigger, I'd have to round that up. But since that's a 1, that means it is just 13.159. But you always do have to go one digit past where you want it to round it to. So we've converted decimals to fractions. Fractions to decimals would be the exact same thing. If I wanted to do 5/6 into a decimal, we just said a fraction is a division problem. This would be 5 divided by 6. 6, of course, doesn't go into 5, so I add a decimal point, put a 0 there, add a 0. 6 into 50, 8 times. It's 48, with 2 left over, add a 0, bring it down. 6 goes into 20, 3 times. That's 18, 2 left over, add a 0, and bring it down. 6 goes into 20, 3 times, that's 18, 2 left over, add a 0. Bring it. And you notice a pattern developing here? At this point, there's always going to be 2 left over, so this is always going to be 3. So this is going to be 0.83333333.
When you're doing fractions and like that, just think about it.
Yep, just like that. You can call it a repeating decimal. Now, only the 3 repeats here, so the bar is only above the 3. Just like if we had 2/3, if we divide that out, you get 0.6666. That'd just be 0.6 with the bar there. But if you had 3/11ths, that's 0.272727, which would be 0.27 with the bar above both the 2 and the 7. Okay. 1/70th, 0.0142857. Notice the 0 doesn't repeat, just the 142,857. And the bar isn't above the 0. Now, something you guys will run into. Let's say you do a calculation and you decide how big a hole needs to be or whatever, and it comes out to be 0.271 inches. You look in your toolkit, you don't have a 0.271 drill bit. Your drill, maybe your drill bits go to the 16th of an inch. Well, the easiest way to do this is you take that 0.271 and you make it into a fraction. And the simplest way to do that is just put it over 1. It's now a fraction. But the denominator is 1, and I want it to be 16. So 1 times 16 makes it into 16. So I have to do 0.271 times 16, which is 4.336. What that is telling me is that this is between 4/16 and 5/16. Which one is it closer to? 4/16. So it's 1/4 inch drill is what you need. 4/16 can still be reduced. Or if you have 0.772 inches, and you want, let's say we want that one to the nearest 32nd. Well, 0.772 over 1, and now it's going to be times 33 over 33. Or 32, sorry, not 33. I don't know where 33 came from. So it's 30 seconds on bottom, 0.772 times 32, 24.7. Notice all it really needs is that first digit after the decimal point. Telling me it's between 24 30 seconds and 25. Which one's it closer to? 25, since that's 0.7, it rounds up to 25. So 25 30 seconds of an inch is the tool you would want there. Now, this is just assuming you want to get as close as you can to that decimal. Some cases, you want to make sure you're always a little bit bigger or a little smaller if you can't be exact. But this is just getting as close as you can no matter what direction it is. Okay, well, you guys got a few minutes left to work here. Let's give you, out of the book, page 63 to 65, 1 through 73, the odds, and page 72 through 75, 1 through 67, the odds.